Google's Spark agent runs all night. Now, on to the AI
In
learning.
this session, we compare Google Spark with Cowork across 12 controlled tests. Our goal is a fact-based verdict on when to use each agent platform. All materials come from DDS Vibe Academy, Class 65, and the program is freely accessible for your teams. Traditional chatbots wait for prompts and then stop. Agent systems behave differently. They accept an outcome, plan steps, and iterate until the work is complete. Spark operates as an outcome-driven agent, automatically naming, planning, acting, and finishing tasks for you. Gemini Spark is powered by the Gemini 3.5 Flash model, running inside Google's Antigravity harness for orchestration. Each Spark task executes in an isolated, short-lived cloud VM. This design keeps workloads separate from your device and lets Spark continue working after you disconnect. Spark was announced at Google I/O 2026 and is currently available in the US as part of the Google I Ultra Beta. Access requires the Ultra subscription at $100 per month. Remember that Spark capabilities remain in active beta and are subject to change. Spark exposes 3 core primitives. Tasks are one-off agent jobs you describe in natural language. Skills are reusable instruction blocks applied automatically. Schedules act as time or event triggers that launch tasks, such as building a daily research digest for your team. There are strict limits to keep Spark predictable. At most, 15 tasks can run at the same time, and heavy usage is capped. Schedules execute at approximate, not exact, times, and new schedules pause when caps are reached. Design workflows with these ceilings in mind. Integrations with Spark are opt-in and disabled by default to protect data. Once enabled, Spark can work with Gmail, Drive, Docs, and Calendar. At launch, MCP partners include Canva, OpenTable, and Instacart, allowing agents to coordinate communication, design, and basic logistics. During task execution, Spark can call several tools. It grounds answers in live Google search, uses a remote browser to act on web pages, runs Python code on a remote machine, and writes outputs natively to Drive and Docs. Together, these tools enable rich, automated workflows. Safety is built into Spark's baseline. The agent confirms any high-stakes actions before execution and flags steps that involve spending, sending emails, or editing calendars. It includes prohibited task detection and follows prompt injection defense guidance to reduce operational risk. To get reliable outcomes, we use a 5-block intent recipe. Define the outcome in one clear sentence, then list constraints on tone and format. Provide context sources, specify a verification test, and finally set a gate describing where Spark should stop and surface uncertainty. We always design the gate before the goal. Start by writing what Spark must not do on real accounts. Diagnostics panels then distinguish reversible actions from irreversible ones, which require explicit approval. This single habit prevents most serious incidents with autonomous agents. Spark excels in 4 domains. It conducts autonomous research with verifiable citations, turns complex data into concise strategic recommendations, generates and executes code in a self-contained way, and produces complete, ready-to-share text packages directly inside Google Workspace. Spark's Loop breaks in rich media workflows. It cannot access VEO, and there is no native image generation within the autonomous loop. As a result, end-to-end media production pipelines fail, and third-party design tools require carefully managed permission gates to be safe. Common failure modes include founders accepting rough, code-generated OpenCV clips as final assets, or routing thumbnail work through Canva or Python tools without review. Copywriting can drift into generic corporate tone, and long narrative drafts may contain invented details. Spark's own logs highlight current gaps. Video generation remains challenging. Baseline system video tools are unavailable, and FMPEG cannot be used. Only OpenCV can write MP4 files, which constrains quality. Any video-centric workflow therefore needs external tooling and oversight. In our first scorecard, Spark leads for research with citations, while Cowork wins on brand voice, images, and video through VEO. For charts and self-contained coding, the platforms tie. This shows Spark is strongest for analytical work, whereas Cowork excels at visual media. The second scorecard deepens the picture. Cowork performs better on code execution tied to repositories and on reusable skills. Spark wins at turning data into recommendations and at workspace-ready outputs. Overall, Cowork takes 6 categories, Spark 3 with 3 ties. We therefore recommend a hybrid handoff. Spark drafts a well-researched, cited text package in docs. Cowork then grounds that draft in your voice assets, produces native images and VEO intros, and finally publishes with metadata and scheduling. Each agent plays to its strengths. To operate safely, follow 5 disciplines. Define gates, run dry runs, control scope, manage the data body, and plan the handoff. Avoid arming untested schedules, granting blanket workspace access, or trusting Spark to produce final media. These are high-risk anti-patterns. Looking ahead, expect a macOS desktop app for local files and broader MCP integrations. For now, this curriculum remains free. No paywall, sign-up, or certificate, just practical work. Teams interested in continued updates can subscribe through DDS Boston for future modules.